is lesson 8 on projectile motion, and this is for year 12 physics. And in this lesson we are going to learn about how to solve a problem where you have the whole projectile motion. The previous lesson was just half a projectile. So here's the question. A soccer ball is kicked at 15 meters per second at 20 degrees to the horizontal. Calculate how far does the ball land on the ground. So what does this mean? So this question means a soccer ball is kicked at 15 meters a second at 20 degrees to the horizontal, and we need to find out this horizontal distance. Now, in order to find this horizontal distance, because it goes at constant horizontal velocity, we can use v equals d over t, and we need to find out what is that range or the distance. However, we don't know the value of v or d or t. This velocity that's given is not the horizontal velocity. This velocity is actually a sum of the horizontal and vertical velocities. So the first thing and the other thing we need to keep in mind is that the time taken to go the whole way is twice the time it takes to go halfway, which is the same time as it takes to go from the bottom up. So this is how we solve these problems. I always separate my horizontal and vertical quantities, and in order to find the time taken to reach maximum height, we need to know what is the vertical component of the initial velocity. So I need to know that, and this is opposite, so it's sine. So it's 15 sine 20, and you get 5.13 meters per second upwards. Now, knowing the initial horizontal velocity, we know the velocity at the top is 0. Acceleration due to gravity is 9.8 meters per second, but I put the negative sign because it acts downwards. We're trying to find the time. You use Vf equals Vi plus At, and you get the answer to t, which is 0.52 seconds. Now that's the time it takes to go halfway. So the total time of flight is twice that. You get 1.05 seconds. Now looking at horizontal quantities, the horizontal component of the velocity is 15 cos 20, and it works out to 14.1 meters per second. So now we know the v and we know the t, so we just got to get that distance, which is the range, which is horizontal velocity times total time, and you get the range. And that's how you solve a problem on